This video we are going to talk about center of mass. So this is an introductory video to center of mass. Let us first try to understand what is center of mass. Let us say that we have a irregular shaped object, right? The center of mass is that point in this object, right, where the total mass is assumed to be concentrated. So this is the center of mass, and let us identify it by C. This particular object consists of a large number of particles, right? And each one of these particles has its own mass. Center of mass is that particular point where the total mass of all these particles acts. So it's a point within the body. That means if supposing a force acts on this particular object and this body accelerates in this particular direction, let us say with acceleration A, it is equivalent to saying that the force is acting on center of mass C and the center of mass is accelerating by A. So this point is a kind of point which has the total mass of the body, and moving this body with an acceleration A is equivalent to moving the center of mass where the total mass is concentrated with acceleration A. So this is the concept of center of mass. Now this is with reference to one object. Let us say we have two objects. Let us say we have object 1 and object say for example 2, and their masses are say for example 2 kilograms, right? 2 kilograms. So both of them are 2 kilograms. Now if I look at these two particles as a system, then what would be the center of mass of this particular system? For the sake of understanding, I can imagine that these two are metallic kind of spheres of mass 2 kg, and they're connected by a thin and extremely thin rod of negligible mass, right? So it doesn't actually exist, but for understanding purpose we're going to look at this, and therefore this particular thing, this entire thing becomes a system, and we will call this a two-particle system. So where is the center of mass of a two-particle system located? Quite obviously you would have guessed that if these are the two particles, then the center of mass would lie exactly at the midpoint of the line joining them. So this would be the center of mass of this two-particle system. Now, how did we arrive at this? How did you guess that it would be at the center? That is because the two masses are equal, and by intuition we know that the center of mass would be at the midpoint. But let us try to find out the mathematical equation or the mathematical formula for finding out the center of mass. So what I'll do is I will put this two-particle system on a coordinate axis, let us say y and x, and let us say this is 1 centimeter, right? With this distance are in centimeters, 2 and 3 and 4, and similarly we have over here 1, 2 and 3. Right? Now if I look at the x-axis, this is the origin. If I look at the x-axis, then x1, right, that is the x coordinate of the first body is 1 centimeter, of course, and the x coordinate of the second body is 3 centimeter, and the location of the center of mass is obtained by xcm, right? That is the x coordinate of the center of mass is obtained by taking x1 plus x2 divided by 2. So we can just cross check this. X1 is 1 plus 3 divided by 2, that will give me 2, and you can see that the center of mass is at x coordinate 2, right? So this is the way the method for finding out the center of mass of a two-particle system. Quite obviously you have guessed the fact that we have taken a very simple case where the two objects are placed in such a way that they are parallel to the axis. What would happen if this two-particle system is not parallel to the x-axis or not parallel to even to the y-axis? So what I'll do is I'll again take the same two system. Let us say this is the two system, and again I'll take the x and y axis, and let us say this is 1, let us say this is 2, 3, and let us say this is 1, 2, this is 3, and let us say this is 4, right? Something like this. So let us again, the masses are 2 kilogram, and but in this case the two-particle system is not parallel to the x-axis nor to the y-axis. Now in this case what I'll have to do is I cannot obtain the center of mass only by taking the x coordinates. I will have to also introduce the y coordinates. So for the first particle, let us call this particle 1, particle 2. For particle 1, x1 is 1 centimeter and y1 is 2 centimeter. X1 is 1 centimeter and y1 is 2 centimeter. And for the second particle, x2 is 3 centimeter and y2 is 4 centimeter. Right? So these are the coordinates. Then the x coordinate of the center of mass will be obtained by x1 plus x2 upon 2, and the y coordinate of the would be obtained by y1 plus y2 by 2. Just to clarify, we are taking 2 because there are 2 particles, because it's a 2 particle system. If there would be 3 particles, we would take 3. Okay, so this will give me x1 plus x2, so 1 plus 3 by 2, that is 2, and ycm would be equal to 2 plus 4 upon 2, so 3 centimeter. So the center of mass would be a point 2, 3, and you can see over here this is 2 and this is 3, so this would be the center of mass. And that's what intuition also tells us, that when both the masses are equal, the center of mass would lie at the midpoint of these two axes. So this is the method for finding out the center of mass of a 2 particle system. This is a very simple case still, because we are taking the masses of the 2 particles as same. In the next video, we will try to understand how to find out the center of mass of a 2 particle system when the masses of these 2 particles are not equal. So for example, this mass would be 2 kg, this could be 5 kg, then how would the method change, right? So that is something which we will discuss in the next video. Thank you.